What? No, it's like.
All right. Front slope. Oh, got a pen again. Slope is rise or run. Love it. What else you know? You've got a formula for that. I love it. What else you got for me?
Slope is defined as a change in y divided by the change in x.
Change in y or delta y over change in x, which is delta x. Love it. So far, we're doing good. What else you got for me? You got more. You got a lot more. I know you got more. Okay, let me start off with the mathy answer first. Okay? With me? If I have a kid is riding a squirrel.
Yes, physics.
And she rides. Talking about this. Okay, she rides a squirrel. So her distance time graph looks like this. She rides a squirrel, then she rides a squirrel, then she does this with this, and then she rides like this, and then she does this for a while. Actually, let me make a better graph. Here she goes. Here we got it. Here we got it. She's gonna do this, and then like this, and then up to here, and then like this, and then like this, and then like this. Okay. Tell me the story, Kirkland, of this child sitting on a squirrel. Distance time graph. Distance time graph. So I got distance time graph, and I don't know what you learned in other classes, so don't use that at all if you think about it. So tell me the story of this child on a squirrel. Yes, that fits the graph. Let's go.
This
child gets on a squirrel.
And it slowly starts to feed it nuts as it works up towards a really fast pace, and then it slowly.
Is it going faster or is it going slow? What is it doing during this time? It's going the same distance every second, right? So wouldn't it be going constant speed?
Yeah, sure.
Okay. Then what happens? Goes faster. Okay, and then what happens here? What constant speed is this? It's got distance, not changing its distance, right? So it stops. So this squirrel goes some slow speed, goes fast speed, then stops. How'd you know that? What about the graph did you read? You read slope, right? Steeper slope means faster rate. Change in y or change in x is how fast it changes, right? Bigger distance for a little bit of time means I'm going faster. Does that make sense? So slope means rate. There's one other place where you certainly have, living in Incline Village, at least heard the phrase. Yeah, your whole town's named after a slope, right? Right? That's what an incline is a slope. But that's not what I meant, but that works. Okay. What about roofs? I heard somebody complaining in calculus class that they had to shovel their roof, and I said, your roof looks like this, right? He said, yes. I said, did the guy next door with a roof like this have to shovel their roof?
No, sir.
Why not?
It slid off.
It slid off because of the bigger slope. So slope comes into meaning. Now, I'm going to give you a little hint for those people going off to calculus land. The first semester, we're going to do nothing but calculate slope. That's how important it is. People that are taking physics class know that the slope of a curve or a slope of a line has meaning. It tells you how fast something's changing. Unless you're Miss Erickson, in which case you're playing around with your phone instead of paying attention in class.
Oh my gosh,
So, slope has profound meaning. But right now we're just going to graph lines, so that's okay. Now, to graph a line, I'm going to run through it. So you guys should all remember how to graph a line based on this formula, which you're all familiar with. Seen it? Well, what is the pieces of this formula, Mr. Baldwin?
So M is slope.
That's slope.
B is y-intercept.
Y-intercept. These are the dependent and independent variables. Agreed? Okay, so if I'm going to graph something, I simply go to where it crosses this, and if it says -4 or whatever, this is my y-intercept. And then to find the next point, I'm going to go rise over run, which Ms. Kirkland gave to us to put a second dot, and then I'm going to, once I have 2 dots, I'm going to go whoop and be done with this, right? You all can do that. Okay, one other thing I need to hit then, while we're talking about it, I need you to be able to find the zeros. Find the zeros. This is a new and hip term in mathematics. We didn't used to call it the zeros. So you guys are all thinking, wow, it's cool then. So I want to find the zeros of a function. What is the zeros of a function? Miss Ryan, do you remember what the zeros of a function are?
It's where y is 0.
It's where y equals 0. So if I am looking at a function, say x squared minus 4 equals y. If I want to find the zeros, what would I do? Where y equals 0. So what am I going to do? Put y 0, right? And then what do I do? Add 4 to both sides. I'm going to solve it, right? So get x squared equals 4. And then we're going to get x equals what? Oh, such a trap. Thank you. 2 and -2. So that would be the 2 places where this thing crosses the x-axis. Okay? So that's how you find the zeros. You set the y equal to 0 and you solve for what values of x give you that value. That tells you where it crosses the x-axis. Good? Everybody good? All right, blow through the... You're good? All right, everybody through the back and go. This should be really easy for expert students like yourselves.